Hi one and all. In this video, we shall learn how to write the VHDL code for 3 to 8 decoder. More specifically, we shall learn how to simulate and verify the working of 3 to 8 decoder using the Xilinx design suite. Right? Okay. Before directly understanding the VHDL code of 3 to 8 decoder, we shall understand 3 to 8 decoder at a high level, and then we shall understand how to write the VHDL code for 3 to 8 decoder, right? So as the name says, 3 to 8 decoder is a circuit, okay, which will accept 3 inputs and produces 8 outputs. So 8 outputs. So 3 inputs will be there. It will accept 3 inputs. I will label the inputs as A, B and C, and I will label the output as Y0, Y1, Y2, etc. Y7. So totally 8 output lines will be there and 3 input lines will be there. Hence it is called as an 3 to 8 decoder. So how this will work? See, this circuit will work based on the input values. So suppose if the input value is 0 0 0, okay, in this case it will select Y0 as output line out of 8 output lines. So this is how it will work. Suppose if the input value is 0 0 1, then in this case it will select Y1 as the output line out of 8 output lines. So at a time only one of the n output lines will be selected, and which output line it will be selected, it depends on the input values. So this is how 3 to 8 decoder will work. Clear? So with this idea, now we shall try to write the VHDL code for 3 to 8 decoder. So as you can see here, we need two variables. One is for input and one is for output. See here, according to the manual, we shall use din variable for input and we shall use dout variable for output. Clear? And as you can see here, how many input lines we need? 3. Hence here we are going to use a vector or array concept of dimension 0 to 2, means totally 0 to 2 means 3. Clear? So and how many output lines the decoder will have? In this case 8. So again vector concept, and the dimension here it is 0 to 7. Totally it is of 8 output lines. Clear? So we need these two. Clear? Now we shall try to understand how to convert our logic to VHDL statements. It is very simple. As I said, dout is output variable, right? The value of dout depends on the input, right? So here if the din, I mean input in this case is 0 0 0, then which output line will be selected out of 8 output line, in this case Y0, right? Hence first Y0 line will be set to 1. The rest of the values of Y, like Y1, Y2, etc., I mean up to Y7 will be 0. Clear? Else if the din value is 0 0 1, then it means according to it should select line Y1 as the output line. So hence the second bit, I mean which represent Y1, should be set to 1, the rest to 0. Similarly if the value input value is 101, in this case it should select, or it should set the fifth output line. Clear? The rest will be 0. So this is how you need to write the VHDL code for simulating 3 to 8 decoder. Clear? So I hope you understood how to write the VHDL code for 3 to 8 decoder. Now directly we shall jump to the tool and we shall see how we can able to practically simulate and verify the working of 3 to 8 decoder. Clear? Okay, so now we shall jump to the tool. So in order to save the time, I have already launched the tool. This is the design suite. We already have learned about this in the previous class video itself. So always start with a new project and you can give any name for the project. Okay, then don't worry about the default values, and every project should have one source file which should be of VHDL module. I will give the name of the module as M, and this is important. Here we need two variables, one is din and the other one is dout. Okay, the direct din should be used as input, dout should be used as output. and both should be a vector, and first one should be of vector of dimension 0 to 2, second one should be a vector of dimension 0 to 7. Clear? Click next, finish, next, next, finish. Okay, automatically the tool or the IDE will generate the statements. Don't worry about this. So you have to write the logic in between begin and end. So here the logic is, so you need to set the value of d out. So how we will set the value of d out? It depends on what? It depends on d in value. It depends on d in value, right? D in value. When d in is equal to 0 0, so since you are dealing with multiple bits enclosed within double quote, what should be the value here? So it should be 1 0 0 0. So how many zeros? So totally how many bits? 1 2 3 4 5 6 7 8. Totally it should be of 8 bits. Why 8 output line? We shall check once again. 1 2 3 4 5 6 7 8. Fine, right? Else d naught should be set to, see, this is a single statement, just I am continuing in a new line for better readability. Else it should have the value, so just to save the time I am copying that code and pasting here. And when d in is 0 0 1, then the second bit should be set to 1. Else d out should have the value, I mean if d in is 0 1 0, it should have the value 0 0 1. Okay, similarly if d in has the value 0 1 1, which is 3, this should have the value, this should be set to 0, next one should be set to 1. Clear? Else when d in is, else remember there is no rule that you should start with the same column, I mean here. Okay, for better readability I am aligning. So else if d in is 1 0 0, which is 4, then this should be set to 0 and next bit should be set to 1, right? Then when d in is 1 0 1, then this should be set to 0, this should be set to 1, right? Then when d in is 1 1 0, 1 1 0, then this bit should be set to 0, next bit should be set to 1. Else it should have the value, d naught should have the value, else d naught should have the value, all 7 zeros, finally 1. So end the statement. See, here I am ending the statement, so every statement should be terminated with semicolon. Clear? Now save your work, go to implement design, go to synthesize and check for the syntax. So once this phase is completed, as usual you need to start with an new source, which comes under project. So go click project, new source, and as usual we need to take test bench waveform. You can give any name for the waveform. Okay, don't worry about this window. Click finish. So here d in is the input, d out is the output, right? So you need to set the value of d in such a way that it should have all possible combinations. Means since d in is of 3, see, d in is of 3 bit, 0 1 2, so possible value is 2 to the power of 3, which is 8. So I can use this, or I can use this color as a border. Okay, color as a border. Now initially d in has a value 0. Now move the mouse pointer anywhere in the gray box after this color border, click it, left button mouse click, then enter the value 1. Now what you are doing means that initial value 0 will be set to here, and after this it will set the value of 1. Similarly, after this color border, okay, after this I need value 2. Okay, hence place mouse pointer anywhere after this, but it should be inside the gray box. Press left mouse button, then a window will appear, and then enter 2. Similarly 3, then 4, then 5, then 6, then 7. So all possible values. Then clear? Okay, then save this, okay. Then after that, okay, even if you have forgotten to change this to behavioral simulation, choose behavioral simulation, then anyhow you will find the waveform here. Okay, but my suggestion is, as soon as you get a compilation successful message, use this selection box or drop down box to change from synthesis to simulation. So even if you have forgotten to change this, after providing the input values, you can able to change that synthesis to simulation. Then only you can able to find the waveform. Otherwise you can't able to find the waveform. So you need to be careful here. So select the waveform, go to the process tab, clear, then go inside the simulator, then call simulate behavioral model. So now it is executing. So once it executes, you will get the output window, which is nothing but a waveform only. Clear? Okay, now look at here how to justify this, what you are getting is right or wrong. See, it is simple. Open the output line, clear. Okay, look at here, what is the input value here? Okay, better you take a reference line. So what is the input value here? 0. If it is 0, then out of 8 output line, which output line should be selected as it should be selected the first one here. Don't get confused with 7 as the last line and 0 is the first line. Here according to this experiment, this is used as a first line. Okay, first output line, I mean y0, y1, y2, y3, y4, y5, y6, y7 as per the discussion. Clear? So it has selected, see here it has selected, we shall call this as y0. It has selected only y0 but not others. Y1 is set to 0, all are 0 except this. And if you convert this to decimal value, this is in binary. 1, see here, 1 0 0 0 0 0, this is in binary. If you convert this binary to decimal, then you will get decimal value as 128. That's what you are getting inside here. Similarly, if the input value is 1, so in this case input value is 1, then y1, see, can you see here, y1 will be selected. Can you see here, y1 will be selected and others will be set to 0. And if you convert this binary 0 1 0 0 0 0 0 0, then the decimal equivalent will be 64. That's what you are getting inside the gray box. Similarly, you need to check for 2, 3, 4, 5, 6, 7. So here at this instant the input value is 7. So according to this, the last one will be set to 1 and all other will be set to 0. If you convert this binary 0 0 0 0 0 0 0 1, then the decimal equivalent will be 1, and that value you can able to see here inside this gray box. So this is how you need to justify whether your 3 to 8 decoder is working or not. Clear with this? So with this discussion, we have completed all experiments in software part, and the left out is the hardware experiments, and in the coming classes we shall go ahead with the hardware experiments. Clear? If you have any doubt regarding writing the VHDL code for 3 to 8 decoder and providing the input for the 3 to 8 decoder, and verifying the result. If you have anywhere, if you find any difficulty while simulating it, you please ask me. So I will be here in the campus only. I will help you out in order to understand and to carry out the experiment. So with this, I will end the discussion. So thank you, Alinda.